Sampai tak boleh? Sampai? Oh ya. Enggak. Macam ni pun.
Everybody, now I want to Assalamualaikum semua. I want to start our class. Please be remind that you must off your mic and your camera. Okay. Now we are going to our PowerPoint slide.
Okay, doktor.
Can you see in your screens the PowerPoint? Can you see the in your your mobile phone or your computer the slide?
Yes, doctor.
Oh, okay, right. Okay, that's good. So today we are continue our lessons. Chapter 4 is all right.
Alright.
So this is chapter 4 and leveling. And of course, you know that we call it demonstrate to you about the levelings, how to use the levelings, how we call it to adjust and match the balance about the equipment or levelings. And then you already set up the pad on fields. And then we call it we call it a tripod. And on top of a tripod, we call it your leveling equipments. And then you start take the reading. So this is, for example, that you have, we call it levelings. And here you have, we call it a tripod, and you observe this one. Okay, you are doing something like you monitor and read from the staff. The reading is 1.260, and this is your friends who we call it hold the staff vertically, make sure it's straight, and then after it's straight you take the reading. I think you still remember that. And then below we call it the staff. The staff, right? Still remember that, the staff? You still remember? So below the staff you have, we call it, this one is PEG. P-E-G. So the PEG that you made is from wood, right? It's snoricles. And then these packs, you have many, around 20 to 30 packs on site. Okay, that is the introductions, and then the introduction, and to refresh your minds that around a month ago, what you already, we call it, do it on your field. Okay, all right. So today is, we call it a theoretical part. You already, we call it dance, we call it a leveling, instrument works on site, and then today is the theory. So this slide consists of 2 segments. So today, in within 2 hours, I would like to present to you just one segment. Okay, the introduction parts. And then introduction part is including, we call it introduction of leveling, the purpose, how you are doing your bookings. And then you know that the booking, we call it touch on, we call it 2 technique of booking, rise and fall, and then height of coordination. I think you still remember. But today we are recapping a little bit about a month ago, what already we done. Okay, next slide. Okay, this slide, if you can see about learning outcomes. So learning outcome is mean that after you finish this lesson, after you finish this class, so what is the knowledge you should acquire, you should have to become the ultimately, you are become the civil engineer. All right. So this lecture focus on the surveying works using leveling instrument, okay, using leveling instruments and methods. And after this lecture, the student should be able to, number one, able to understand the principle of leveling in survey. The principle that you know that the leveling is just to measure, we call it verticals. So you have point A and point B. So what is the different height between point A and point B? Either we call it the land become flat, so the difference is zero, and either we call it you have the left and right. For example, like my hand, so you can see a little bit on my we call it right hands is slightly higher than my left hand point. For example, that point A and point B, or we call it point A lower than point B. So that is the principle of leveling survey. And from that, you know the how to make a contour, and then you get the readings, and then you plot the contour. You know how we call it, how much we want to cut out. We call it our works. I mean that's why we should cut maybe to build up the highway, or maybe you want to do the site for the building constructions. You modify the topography based on your building purpose, based on your what you want to construct on site. And number two is able to analysis raw data from leveling survey. So this one number two, that's you already acquired data. Your data is just a number, alright? And then from that you analyze to make it the data happens, and then you plot to become the civil engineering purpose. For example, it's contour. For example, that the value that you know, that's how to make, we call it gradient for drain and so on. And lastly is able to apply the principle of tachometry in order to calculate reduced level of survey point. So the tachometry is, we call it a techniques where using, we call it leveling instrument also you can use it. We call it, you know, we call it the distance between 2 points without measurement using a tape. So we have three objectives here. I should try to cover one number objective number one, learning outcome number one and learning outcome number two. The third one about the tachometry will be discussed. We call it maybe this Friday or next week. All right. So now we are going to slide number 3. Okay. So this is the basic thing that you can see that we have, we call it our topography here. All right. Topography here. So the existing of topography. All right. And you also know that is we call it here is a point. All right. So this one is point the highest and the lowest. Okay. So the highest and the lowest, you are doing average. So you get a straight line. So normally this average, we call it mean sea level. Okay. For example that is a very simple. The lowest one is, you can see that this one is actually is sea condition. Sea condition. So normally we have pasang surut air. We call it tide. So sometimes the water going to become what we so called in bahasa Malaysia is a high tide gauge. So this line, air pasang tinggi. Okay, and sometimes the water tide going down until it's lower. This one is lower. Okay, so from the highest and the lowest one, so we take the center, or we call it, we average that one, and we draw a straight line. So this line we call it MSL, mean sea level. So we know that the level of sea is fluctuated, sometimes rise, sometimes going down. Pasang surut, tide high, low tide, high tide. Okay, So you average it, these two reading, and this is will not do it. The person in charge in Malaysia, or the body in charge in Malaysia, is JUPEM. JUPEM, Jabatan Ukur dan Pemetaan. Okay, JUPEM, JUPEM, Jabatan Ukur Pemetaan Malaysia. So they doing this MSL, mean sea level. Alright. So if we have the point here at the benchmark, BM, we call it benchmark, here point, this point. So you draw the straight line, and then you draw the vertical line. So there is the difference between mean sea level and benchmark. Okay, so when we talk mean sea level, is the average between high tide compared to low tide. Okay, so there is, we call it mean sea level, or in Bahasa Malaysia we call it aras purata air laut. Maybe you have, we call it, you learn it before this or previously at your, we call it school. So they call it in Bahasa Malaysia aras purata air laut. Okay, so if you understand this one, so you know that you can read introduction. So the leveling is the operation performed to determine height of the points on the Earth's surface, right? Then number 2, for introduction of leveling, a relative height or height with respect to datum are determined. So determine, all right, mean sea level and benchmark. All right. So normally mean sea level, we consider this line is 0.00 meter. Okay, that is how we identify 0.00 meter based on the average of the mean sea level. Okay, that is the introduction. Next, we go for, we call it continue. The introduction about leveling. We continue. Still in leveling. Okay. Right. Leveling, this is a theory part. Leveling is the general term applied to any of the various process by which elevations or point or different in elevations are determined. Okay, different in elevation are determined. Okay, number 2 is the comparison of point of height on the surface of Earth. Alright, the third one, and end up from this leveling, we can do a mapping, we can doing engineering design for civil engineer, we can do the constructions. So how about the meaning of constructions? So you can construct the highway after you cut the road, because the road normally we want to make it a flat as soon as possible. If we have, we call it, our cut and fill, you want to cut, but because you want to make it all the road become flat, for example like highway, but sometimes we cannot do it because it's too expensive. So we are tolerate. That's why you can see that we have the verticals. Okay, you can see that our car is not going to straight. So maybe we climb the hill and going down the hill. So I mean that is still we have a vertical curvature on road. Okay, and engineering design mean that you are doing something like how much you want to cut the slopes, how much we call it you import, we call it the soils from the original going to the, for example, that paddy fields. You want, we call it, to make embankments. You know the embankments that you want to put the, we call it, the highway or roads on the paddy field is impossible because the water level is very high. So what you're doing is you're doing embankments. So kita panggil in bahasa kita kita buat tambakkan tanah. Okay, so engineering design. And then for mapping, mapping something like you produce a contour, and from that contour you're doing engineering design, and then you're doing some construction. Of course, this one is theoretical mapping, engineering design, and construction. Sometimes when you are doing engineering design, when you go to site, go to construction, they're going to fail. So you adjust at the constructions. Okay, that is the reality. Okay. Now we are going to, we call it the second part after introduction. The objective of leveling. Oh, normally the civil engineer doing leveling for what the purpose? So number one, the taking of a longitudinal section. Longitudinal section is, we call it something like this. You have, we call it something that highway, right? Maybe this one is 10 kilometer. Okay, so this is the profiling, we call it your earth. So this one we call it longitudinal section. Alright. So you know based on leveling. So maybe this one is 0 kilometer from Permatang Pau. Maybe this one is after 10 kilometer. Maybe we go with Kepala Batas. Right. So that is, we call it longitudinal section. Number two, we call it a cross section. Cross section, that's this one. If you have this road, something the road construction like this. So when you have your eyes, you see from side of, we call it road construction. So you get longitudinal section. Get this one, You get this one. If you see from here, okay, going to this direction, so you get cross section. This one is cross section. So cross section like this. So maybe that's we call it the existing one like this. Alright? The existing road, the existing field, the existing soil shape. So you want to construct the we call it road on top of that. So you're doing like this. Okay? So you fill up this one, make embankment. So this is, you see from this view. So we call it this one cross section. You get it? Okay. Contouring. For example, I will sketch you contouring like this. Maybe you're familiar like this. This is contouring. So this one is a contouring. Contouring, Okay. Setting out level. Okay. Setting out level is mean that you're doing on fields. What you're doing is a grid system. Still remember that? You're doing maybe 20 packs, maybe 50 packs. And this is your equipment. So you observe the point. So this one we call it setting out of level. Okay. All right. Don't worry. If you don't understand, you can ask me. I will answer that. Okay. That is the applications. So application means that after you doing, we call it the survey. We call it in here, we are doing a levelings. So which is, we call it the part that benefited in terms of civil engineering. So levelings, we use this one. We apply this knowledge for the design of highway, for railroads, for canals. You know canal, terusan air, sewerage. Sewerage normally in Malaysia we term as, we call it, normally we have waste. So in the morning you're going to toilets, and then you have the waste. So how you manage the waste? from your home going to the manhole, to septic tank, and then after, if you don't have we call it individual septic tank, you go into the public septic tanks. And how we call it public septic tank for the one area, you are doing something like a processing. So that means sewerage. And more we call it important, because the sewerage, we make sure that all the pipe incline. So normally 1 to 100. The ratio is 1 to 100. And then we have a water supply system. Sometimes water supply system, in reality in Malaysia, we don't have, we call it a level. We put all like this. But sometimes actually we must have inclinations, because it's had a lot of, we call it, for example, that to make constant for the water supply, if you put this as a gradient. Okay. And other facilities having grades line that best conform to the existing topography. So that's maybe you want to do, we call it, remember that you have, we call it a spot of a golf. And when you go to a golf field, they have design, such design that's how to make it, we call it the fields become the world standard. So they have the topography, they will adjust it. So they're using leveling instruments to do or to adjust the level to make it the golf field have the high standard. Okay, right? Okay, now we finish this one. Point 2, still in the application. There is application is where you want to apply the leveling instrument that you have. What kind of project? Layout construction project according to plan elevation. I think you still remember that we call it a tripod, and then we have leveling instruments, and then maybe first or second week I ask you to rotate, we call it the leveling instruments, and then I show you, we call it the bearing 0, 10, 20 until 360 degree. You still remember that? So this kind of, we call it capability that is equipped in the leveling is to do, we call it setting out. So leveling also we use it for the setting out, because the reading of angle from 0 to 360 degree, so you can set up many things. You can set up, we call it the line of pad footings. You want to set up, we call it a straight line of beam. You want to make sure it's 90 degree. You want to make sure it's 45 degree, because the leveling instrument have this capability. And lastly, after you get, we call it normally a contour. Still remember that contour? So from this one, you can doing a cutting. You cut at this point, you cut at this point. Actually, you can calculate the volume of the earthwork. Okay, and others material. For example, that's you are doing a contour, but it's not based on soil. Maybe this one is aggregate that we are dumping. We get this one, so we cut this one, so we can calculate how much the value of the aggregate. You know that aggregate is stones. Normally in construction we're using 20 mm. So we are blasting in the, we call it rock mining, and then normally before we transport to site, we have a large site, large, we call it land, and then we put all the aggregate and make it, we call it stockpile. So alright, stockpile. So we can do, we call it leveling instruments. We take all the reading point here, for example, for the grade system, and lastly we can calculate about the volume of the aggregate or soil or the sand. Okay, we continue about the applications. So still applications. Next, you can investigate a drainage characteristic of an area. It's really important. Normally the students say that, Dr. Basha, how we want to know that our drainage is, we call it inclination based on plan, based on the specification of contract. I say it's very easy. So you just do like this. For example, this is point A for the drain, and this one is point B. So what you do is you just, we call it, take two reading. For example, this one is, we call it your leveling instrument. So you observe, you take this reading from A at point this one, point 1, and point B, and then you are minus, you are A minus B, what you get, and then you measure using a tape the length of this one. So maybe this one, the length you measure is 20 meter. So based on this one, you ratio with 20 meter. For example, A minus B, you get 1. So your inclination is 1 over 20. If the requirement is 1 to 100, so this one is totally wrong on site. So that is how we call it. You want to measure, we call it, you want to check the drainage characteristic you want to investigate. So let me erase this one first before we start. For the second point, sorry, I love to draw. Is it okay for you? Is it okay for you? Okay. All right, that's good.
Okay.
All right.
Okay.
Okay. Hmm.
Now we go, we call it STEAM application. Develop maps showing general ground configurations. Okay, so sometimes we call it, we have a great system. We managed to get all the data like this. Okay, from the reading you have this one at point 1, point 2, and so on. Okay, so you can get a contour. Maybe, okay, maybe I will try, we call it, put a different color. For example, we change it, we call it to the blue color. Okay. So you get the contour like this. Okay. So this contour, all right, maybe this one, you get it, maybe you get this one is 10 meter, this one is next line 20 meter, this line 30 meter, this line is 40 meter, this one is 60 meter, 50 meters, sorry, and this one is 60 meter. So you can see that from this one. So this one is 10 is lower and 60 is the highest one. So when you cut like this, it's something like this. Okay, so this one 60, this one 10. So you get it? Okay, so from this one is objective number 2, develop map showing gender ground configurations. You know that the road either like this, either the slope like this, either the slope like this, or either the slope like this. So from, we call it 0 to 60, we have many form. All right. You finish, and we go for the last one. Okay, study earth subsidence and crustal motions. Okay, if you have this slope, for example, that's today you are mapping the slope like this, right? After 1 month, you study the slope like this. It shows that the slope fail. You have the landslide. So this is we call it the objective for the last one like this. Study a subsidence and crusher motion. Okay, and sometimes we can study, we call like this. You have you study the we call it the land like this. The land like this. So this one is, we call it year 2020, maybe in January. Then after we call it 12 months, you come again, you're doing a survey, so the profile change like this. The profile change. So this one maybe we call it December 2020, eh? So you can see that this one already do what we call it in our field is settlement, eh? Settlement. This one is a landslide. This one is settlement, eh? Okay. So there is, we call it our applications. So next, we call it to equipments. I go to slide number 9. Slide number 9. So I know that you already have auto level. You know this one. You have eyepiece. Still remember that? You have, we call it bubble here. You have, we call it a slow motion screw here. You have, we call it a tripod screw. And then you have, we call it this one. You have foot screw. Sorry, foot screw. Foot screw. This one eyepiece, and this one you have. We call it what we call this one is focusing screw. Still remember focusing screw? And here is you have leveling. Still remember that? Level, split level, level. And this one is slow motion screw. Slow motion screw. Slow motion screw is when you we call it, still remember, there is to adjust the horizontal, left or right, the horizontal movement only. You cannot go up and down. Till up, till down, the leveling cannot do. And number 2, you have the tripod. You still remember the tripod? You have adjustable screw here. You can lengthening the legs here, okay, by pushing this tripod head, all right? And you still remember that we have belting here. So this belt, we call it, the main purpose is how you want to carry out. So this is a belt. And then lastly, you have leveling stuff. So leveling stuff. You have leveling stuff here. And this one is 3 types. Normally they have, we call it, this stuff, normally they have a metric system. And they have, we call it imperial system. Imperial. So imperials, normally they put it in feet or in inch. And for metric, you know that in meter, you have in centimeter, and you have in millimeter. Okay? All right? Another one, you have, don't forget about your tape. And of course, on site, you carry out, we call it the hammer. And for the first one, we need a packs. Okay? And then your safety vest, you still remember? Safety vest. So this is all, we call it the supports of the survey work, especially in leveling. Okay, let's have a good, we call it, let's we go for the principle of leveling. Okay, so you can see that this one is us, us. And this is your instrument you put here. So this is the straight line. So this is, we call it horizontal line. So you still remember that you have, we call it your instrument, right? Okay, this one you have the eyepiece. Still remember that this one is your eyes. This is your straight line. Okay, this is a tripod 1, 2, 3. So this straight line, this line is equivalent to this line, horizontal line. Sometimes we say this one in bahasa garisan Kalimantan. Okay, so in English we call it collimation height. Collimation line. Line. Alright, this one and this one. It's the same one, terminology. And then normally the horizontal line, okay, is we call it same, or we call it in one line with the mean sea level. Mean sea level. Alright? You can see that in the small scale like this. Okay? Because this one we zoom until we out of the planet. So this mean sea level, we call it level line. This one is horizontal line. So actually, when small one, we call it horizontal line. Small one, short distance. But if you continue with your horizontal line, actually is moving like level line. Because you know why? Because the earth we consider rounded. So horizontal line is for short distance. So level line if we complete the survey around the globe. Okay? And we must do the correction, the effect of the curvature. Okay, because horizontal line we consider straight lines, and then we call it the earth is curvature, so we must doing a corrections effect of the curvature. For example, that's you doing a series of leveling from Peninsula of Malaysia, from Perlis to Johor Bahru. Totally, you must do the curvature correction. Okay. So you look at this one, level line is a constant height to mean sea level. So this level line is a constant height to the mean sea level. Right? Is a same actually. They are sit together. Right? Horizontal line normal to the direction of gravity at the given point. So that is horizontal line. Normal mean what? So this one is G force. You know that this one is garis Kalimantan, height of collimation. This one is like this, horizontal line. So this is, we call it normally your G force, right? So this one is 90 degrees. So this is the mean of the horizontal line, normal to direction of gravity to a given point. Because this one we call it normal line, this one is 90-degree line. Still remember that, gravity? This one we call it normal line. The line that perpendicular to the gravity. And make it 90-degree form. Okay, we go for, we call it important leveling terminology. So this is, we call it in leveling, you have terminology. How we must use it, we must apply during the meeting, on the site meeting, during we are going to site, during we are communicating on site, and after we finish and then going back to office, and then we have some discussions, we normally using the terminology. So this civil engineering, we have our terminology, istilah khas, because this is related to our job. It's not terminology we call it to nigger your head, but this terminology to make sure that all the engineers from locals going to international understand, so you have one common understanding. When you have a common understanding, you have a principle, you are become a good civil engineer that can communicate with the terminology. So all subject you have this terminology. Don't forget that this terminology is try to brief you what actually you want to do, what actually you done, and how we communicate with the senior engineer using the technology. Number one in leveling, we call it level surface, level surface. Surface parallel to the mean spherical surface of the earth. I think explained already from the previous slide like this. Okay. And then curved surface and normal to plumb line at all points. So level surface is something like this. Something like this. Maybe you still remember this one. This line, this line. This line. Okay. Okay, vertical line. Any point on the earth surface to the center of the earth defined by plumb line. So plumb line like this one, plumb line. All right. Okay. So there is vertical lines. Our third terminology is level lines. Line laying on the level surface and normal to plumb line, level line. And then we have horizontal plane, plane tangential to the level surface at considered point, perpendicular to plumb line, horizontal plane. And if you say that horizontal line laying on the horizontal plane, it is a straight line tangential to the level line. Then continue, we have elevation, vertical distance above or below the datums known as the reduced level. So we explain to you about the elevation. For example, that's you have mean sea level point here, and this is, we call it your land, and this is your point A. This one line of mean sea level, MSL, and you draw a straight line at point A, and then you draw a vertical line. So different height. So mean sea level, normally this line we consider kosong, 0.00 meter. And for example, like this one you have 10 meter, 10.00 meter. So this horizontal you have 10. You have 10 meter difference from 00 mean sea level to the point A. Alright. So at point A, 10.00 meter, we call it elevation. Elevation. If this 0.5 meter, okay, for example, this one is point B, so we call it point B 5.0. We call it elevation at point B is equal to 5.0. Elevation at point A equal to 10.0 meter. Okay, I think you're quite clear about elevation. Now we go axis of telescope. You still remember that you have a telescope, and then you have line joining the optical center of the objective to the center eyepiece. Okay, so line joining the optical center of the objective to the center of eyepiece. So you can see that when you have your telescope, for example like this, you have your telescope, you have eyepiece, you have your zoom, you have knob here, this one is your eyes. So you see through. In the telescope, you can see that the axis of the telescope. Line joining the optical center of the objective to the center of eyepiece. This one. So this one happened in the telescope. Line of sight. Line of sight, you still remember that you are read, we call it pandangan belakang, pandangan hadapan, back side, forward side, or intermediate side. So this we call it line of sight. Line of sight, where you are read the reading from your eyepiece going to telescope and then going to telescope, you target to the staff, we call it line of sight. So I can sketch line of sight like this. So actually line of sight is sometimes they call it eyes line. Eyes line. Okay, next we are going to slide number 14. We still continue. Axis of level tube or bubble tube and imaginary line to be longitudinal curve of the tube and its points. You still remember that you have, we call it a level tube or bubble tube, alright? And then you must put, we call it in the center, the bubble. If the center mean that the telescope is right, is level. If we call it this bubble going to this point, for example, point 1, or going to point 2, mean that your telescope is not level. We cannot accept before we are doing our leveling work. We must do like this. Center is correct. Okay? So actually, it's an imaginary line to the longitudinal curve of the tube as its point. That is the terminology. Height of instrument, HI. So you have, we call it your leveling instruments. You have, we call it your tripod. So you measure from the center of the tripod until ground. So this one is a HI. So HI is a height of the instruments, HI. So normally we measure using a tape. Okay, now I think you still remember it's a backside. I think we call it, I explained to you already. After we set up our equipment, for example, that we set up these equipments, then we measure to the staff. The first reading we take, for example, 1.21 meter. This one we call it backside. Then you measure for the second point, for example, like this. So you get 1.25. So then we consider this one is the backside, this one is foreside or intermediate side. So backside is the first reading you take after you set up the instrument, right? So next we have foreside. I think already we call it explain to you, a staff reading taken on a point whose elevation is to be determined. The last staff reading and denotes the shifting level, also called minus side. Intermediate side. So you have, for example, that's like this. You have your first staff, second staff, third staff. This is your instrument. So you read this one is a backside. You read for this one is we call it intermediate side. And you read to this leveling, we call it the last one, foreside. This one backside, because we're the first one. And this one is, we call it foreside, last one. And between backside and foreside, you observe another point, we call it intermediate side. So I think we already covered this one. Okay, setting up a level, I think we already doing this SOP, extend the length of the tripod at shoulder level and set up above the control point. And you must remember the shoulder level must come from the person who are very low is compared to other. Mean that orang yang paling rendah. If not, orang paling rendah tidak dapat melihat alat kamu. Okay? Mean that when you to set up the shoulder level, or we call it a chest level, you must measure that in your member team, the person, he or she, that is not tall. I think you get it because you already understand. And if we select the tallest one, the shoulder level, so it's become problem to the people who's not really tall. All right. Screw the lower plate of instrument on the head of the tripod. So you remember that you have the tripod and then you have the head. So normally when we want to screw up using the tripod screw, your head must going down and see exactly where the foot screw going to the instruments. You must make sure this one is straight 90 degree. And if we screw up tightly. Screw dengan ketat Okay. Third one, center circular bubble using foot screw. That means that you have 3 foot screw. You adjust your bubbles to make sure in the center we have 3 steps. First, second, fifth, second, 3 cycle. Alright. And then you have eliminate parallax like this. In your telescope, you have a reading like this. You must make sure that your eyepiece, you adjust your eyepiece, you rotate, or we call it left or right, eyepiece, this one eyepiece, to make sure this target clear. You adjust the eyepiece, because you want to eliminate the parallax. Mean that don't see this one is very blur and it's not visible, and then you get the reading. So this one we call it crosshair. Crosshair. Make it clear and make it visible. Unless your reading is we call it, it's not really correct. And then center bubble tube using 20 screw before every reading tilting level. That's one. This is a very good. We call it SOP. After you get, we call it maybe first you have, we call it backside. Remember that, and then we go for the 18-minute side reading, and then we go the last one is we call it foresight reading. Okay. So after you finish take the first one backside, you go into intermediate, you must check your bubble. Are they still in center or not? If not, you must adjust it. If something like this, you must adjust. Okay. And then you go, we call it foresight. Still again, check either this condition or this condition. This condition is wrong. This condition is right. Okay. You check the center bubble at any time you are doing your observations. All right. I think we already discussed this one in we call it the lab ones. How you want to adjust, you know that. I think I can skip this slide number 17. And then we already discussed parallax. You want to eliminate parallax, and you must adjust. Remember that this is your telescope, your eyepiece. If you adjust, make sure that you get on top here, you can get like this. Clear horizontal screw, horizontal line and vertical line. So this one we call it crosshair. So this one is horizontal crosshair. This one is, we call it a vertical crosshair. Right? So using eyepiece to make sure that we are eliminating the parallax. Okay. Next slide. So this is the process how you eliminate the parallax. Make sure that horizontal and vertical and image appear is a very clear like this. Okay. So you adjust. Okay. This is one of general procedure. You can see from this one. I zoom first for you. Okay, so you have the instruments, the same instrument. You can see that they put in point 1 and point 2. It's leveling instrument, and backside is mean that the first reading, and you can see that intermediate side is the second reading, and fourth side is third reading. Then they move the instrument to point 2. So they observe back at point C. Okay, before this, point C is a foresight. Now become backside because we set up this equipment and then we take the first reading like this. So this one we call it change point, CP. Point C is CP, where the point we continue our survey works. Okay? Alright, then we monitor for the foresight. So we get this reading and the job is finished. So that is the general procedure to show you clearly about backside, intermediate side, foresight, you have backside, you have foresight. So here you can see that the exercise, we have no intermediate side. Okay? And you can see that this one A is a black one. This one is TBM. Temporary benchmark. Temporary benchmark we refer to line 0, mean sea level. Still remember MSL? Alright? So you can see that mean sea level to the point HI, so you can get A. So the reading of A, vertical reading. So from point B to the staff reading, we can get HI. We call it we got it the reading, vertical reading. Okay. So and then you have point C. Okay. Then you have the reading at point D. Okay. For example, if you have, we call it height of elevations. So from here, for example, that maybe TBM, the value is 100. Your staff reading is 1.21. 1.21. So the point reading here at H1 is 101.21. So the reading here is 101.21 meter. You get it, class? Okay, so this is the principles. And next, we call it a type of leveling. So this is the dumpy level. So you can see that this is, we call it the long history one. We not use anymore. And this is the old dumpy level. Next, we have generation, second generations. We have tilting level. Okay. So the tilting level is very, very interesting because it can, we call it the revelations. The revelation from dumpy level going to tilting level. Okay. So last 20 years ago, I using these ones during my exercise at IKM, Barang Mara Sungai Petani. Now we have you using this one, auto level, automatic level, this one. Okay, you have this one, You have auto level. It's a very, very new one, very creative, right? So this is how we call it the constructions inside the modern one. Okay, automatic level or digital level. Okay. Okay, this one is two pack test for a tilting levels. I will explain to you later. Because this one is, you must understand the basic first. This one also two pack test. So I will explain to you why we're using this two pack test. Why we are conducting two pack test. Okay. The purpose is very easy because we want to check your leveling instrument, your leveling instrument is in good condition. We want to check. This is the main objective. Okay. So what we do now, for the first one, we call leveling instrument. This is the tripod. This is the, we call it the leveling instrument. And you have staff 1, staff 2. And the distance also we fix D1 and D2, normally same. And we are measuring this one. This one is, we call it horizontal line. This one is upper stadia. This one upper stadia for B1. This one is the horizontal. So we read at the same distance. The reading must be same because the ground is flat. If the reading is not same, mean that your leveling instrument is out. You cannot use, you cannot use that anymore before you doing the calibration. Kelly, as engineer, normally check the certifications. Either the leveling instrument have this one, calibration. If no certified or the letter or any certificate in paper form, you not allow this leveling instrument enter to your site. It's totally wrong. Okay, all your readings, all your works become waste. Because this one also, this one is using a 2-pack test, but they have 2 packs, this pack, two stuff, all right, and at 2 different positions using this one. So this one also you have a certain angle and degree, so you calculate by mathematics. If your theory using a mathematic calculation is not matched with what you are doing on site from your practical, it means that your instrument is already gone, or you need a repair or doing a calibration. Calibration. This one, sorry, a repair you must be repair, right? Okay, that's good. So I would like to highlight again this, we call it slide number 35. This is your task to make sure that the contractor or the surveyor doing this test, before they bring the instruments to your site, if they still use, we call it the instruments who are not really good on your site, they take the readings and you start to get the data, you analyze and you start to design, is totally wrong. As a civil engineer, you are not doing this, but you know how to handle this one. If the surveyor is the junior one, if we call it, you must conduct by your own, or you can have the alternative how to check, we call it roughly, how we call it, your instrument work very well. Okay, and if you check the instrument is not correct, and then you advise them to go for repair of the doing calibrations, and when they're coming back, they must have the certifications saying that that equipment is already repaired and calibrated by the certified company. Then you can use that instrument on your site work, unless you cannot allow it. This is your job as a civil engineer. Okay, there is booking method. I already explained to you about rush and fall method, and then I already explained to you, we call it a height of collimation method. We have, I think, you still remember, right? I think a month ago I explained to you. I think for 2 weeks. All right, but again, no problems. We again we see this slide. Okay, this 27 slide. So what we have now is, number 1, you have your leveling instrument at point C, right? Point C, this one. Then you observe at point A. then you observe at point B, right? So this one you know that is a backside, this one already foresight. Pandangan belakang, pandangan hadapan in our bahasa, right? So you can see that at point A, your observation here, the reading is 3.222. Meanwhile, for point B, you observe at this point, you get 1.414. So if you minus this one, 1.414 with 3.222. Okay, normally to make it easy, so we understand that like this, 3.222 minus, right? 3.222. Oh, let me do some adjustment first. Okay, 3.222 minus 1.414. So there is, you get the value here. Alright? And then another thing you must remember that if we have a reduced level here, reduced level that maybe you have benchmark here, 128.480. So if you want to know based on reduced level, so this one, you know, the height from the staff reading is 3.22, right? This one is from the staff. This one from the mean sea level. Your normally we refer your benchmark or your TBM. Okay. So what is the reading here based on this one? So you just plus. What you plus? 1, 2, 8. 0.480. You plus with this one. 3.222. So you get this one. So you get this reading. Okay. So the difference is this one is based on mean sea level. The answer. Mean sea level. Alright. So the value here is just representing the different height. Like this. Minus this one. Okay. So you get the different height. Different height between this point and this point. You get this value. This one. Okay. The different height. But this one is based on mean sea level. This one is based on value. But again, one we measure from here to here. One we measure from here to here. So again, the principle is show that the difference between point A and point B. That's all. Let we continue about the second case study. Alright? So this one is different, opposite. So you have point A here, you have point B, and of course here we have point C. Alright? Point A, you observe 3.222 at this point. And for point B, you have 3.484 meter. Okay? So if you minus 3.484 with 3.222, the result is you get the difference between A and B, like this. So this is your results that you get this one, this value. So your value is, for example, X. Okay? If I have reduced level, and then I have, we call it this reading. So my reduced level, existing reduced level, 128.480, you plus with 3.222. So you get this reading. So from this reading, you minus with 3.484. Okay, this reading you minus with this. So you get the point B. But the calculation based on reduced level. You mean that point A, point B, you are referring to mean sea level. But this one, these calculations will not refer to the mean sea level. We straight away minus it. So normally for a civil engineer, this one is really important. We're dealing with our side with the mean sea level. Why we dealing with mean sea level? Because we don't want our site flooded. Kita tak mahu site kita banjir. So, kita tengok reduce level ni sebab because reduce level is tell us either your site is easy to flooded or not. We don't want floods. Because reduce level, we are refer to mean sea level. Air pasang surut naik mean sea level. So that's why for the civil engineer in project, yes, we are considering this one. But this one is a concept theoretical. We are learn at the university. I think you understand very well about this one. Okay, so here how we say that height of collimation. For example, it's very easy. You take reduced level here at point A, 1 to 8. 1 to 8.480, right? You plus with this stuff reading. Because this one is this height, right? It's continue actually. So our value is 3.22, right? 3.222. This one 480. If you plus, you can get this one is 2. This one is 0. You have 7.83. You can get 11. You have 3. You have 1. So this value is this line value. So 131.702. This is we call it height of collimation. This one, height of collimation. Okay, height of collimation mean that this one is, you can see that you see from the telescope, right? Okay, you observe from using telescope, right? So you compare it to the reduced level, you compare it. So you get height of collimation, you compare it. Okay, but if this value you minus with this value 1.414, you minus it. For example, you minus it. Okay, so what we have now is actually when you minus, you get the value here. So this value is, we call it at point B. Still we consider this one is the reduced level at point B equal to x point x like this. So there is, we call it how the height of collimations terminology we're using in calculation about the rise and fall between point A and point B. This one also the same principle, and if you do a booking, okay, number one, we have a rise and fall method. I enlarge the image for you. I'll try to enlarge. Okay, it's a little bit smaller. Okay, right. So it's a full version. If you can see this one, so first we observe a point upon backside 0.63, then we observe intermediate side, then 1.946, then we observe 1.008, still intermediate side, then we observe in between backside and foreside, again intermediate side 1.153. Lastly, we are finished at the foreside. We must remember that we in one set we just have one backside, we just have one foreside, but we can have many intermediate side. Okay, because backside is the first one, foreside is the last one, intermediate side is in the, we call it the reading in between backside and foreside. We can have many in the constructions, and we have the second data. So they move the equipment. You still remember the change point. So change point means that foreside and backside in one parallel line. So here we can see that CP at point D, change point. So from this one we have backside, we observe to the intermediate side, the reading is 2.270. Then we have another set of intermediate side reading 1.218. Then lastly, we are stopped at the foreside. So all we call it the set of leveling works must start with backside first and then finish with only one foreside. Right. So we have this one is station 1, we have this one is station 2. Meanwhile the distance at first point at backside is 0. We going this one for first reading 20 meter, 40 meter, 60 meter until you get 140 meter the last reading. And benchmark on, you mean that below this point, you can see this one, aras purata air laut or benchmark 98.76 meter on AOD, mean that above of the term AOD, or you can see that benchmark. We refer this one based on mean sea level. Alright? Okay. Grab here. So this is start at station A, start at station B, station C, station D, where we occurred double reading here. Double reading. Double reading. So you can have change point at point D like this. And then we have point E, point F, and point G. So this is horizontal distance. Which one using a tape to measure? Tape. This one. Horizontal distance, HD. I think you already done it on our field. Okay, alright. So we go for the next slide. What happened is, okay, here you try, we call it to calculate. Okay, so first we have what? Here like this. Okay, you have, we call it a backside. So you minus with the intermediate side, so you get let me enlarge a little bit, make it clear. Okay. All right. So you have, we call it this one, backside. You minus with an intermediate side. You minus, so you get 1.283 meter. So you're going to fall. Why fall? Because 0.63 is smaller than 1.946. So if we call it, you're doing a mathematical formula, the answer is become a negative. So because of negative, we put this reading under fall. Mean that 0.63 is higher than point staff A, 1.946 meter. Okay. Then from the intermediate side, we subtract to the intermediate side. From this one, we're going to this one. So I should change, we call it the pen color, going to green now. Okay, so this one 1.946 minus 1.008. So you get this reading 0.938. So that put it under positive Y because 1.946 is higher than 1.008. So you put it in the positive. Okay. And again, you can see that intermediate side minus with intermediate side. Again, we change the color. Now we're going to, we call it something like light blue. So again, this value 1.008, you minus with 1.153. Okay. So you get the value. All right. This one. 0.145 stay in 4. Why 4? Because this value is lower than this value. Then lastly, 1.153 you minus with the 4 side, 1.585. So you get this value. Why you put 4? Because this 1.5, 1.153 is less than 1.585. So you get it negative. Okay, and you repeat all this procedure. You repeat all this procedure, right, to these operations, to this step. Okay, I think you understand. Let me wrap first. Okay, now I want to focus on the value that's the next step we must finish. Okay, so if you get, we call it this one, after we call it from your backside, you minus with 1.946, you get fall 1.283. So this value is a minus in front. So if you get reduced level 98.760, where we copy straight away from this one, we just copy, right? Copy, okay, this one must be minus 96.760 minus 1.283, you get 97.477 meter. This is, we call it a reduced level. So you must understand that this set of reading is, we call it from our raw data. So now this portion, we try to make it as practical. We compare it to the mean sea level. So 98.67 at point, this one. So first point is mean sea level, right? So we copy this one and then we minus. So we get 97.77, 98.760 minus 1.283, you get 97.77. Next, 97.77, you have this one. You can see this one is positive. This one you plus this one. First, this one you minus. Why? Because in the column fall. This one plus. Why? Because in the column of rise. So you plus. So you get 98.415. Right? And then again, you have this one. negative. So 98.415 minus 0.1145, so you get 98.20. So that is how you calculate the reduced level based on rise and fall. The calculation reduced level based on rise and fall. Okay, and you repeat at this portion. You repeat at this portion. So the main keyword, how to calculate reduced level, if the value going to fall you minus, is the value from rise you plus. Okay, minus plus. Okay, that is how we make a booking to make sure that we have very valuable data. What data? This data we want. Because we want to plot to become a profiling profile. Then we plot something like this based on this data. Okay. Hopefully you understand this one. We have another maybe 50 minutes more to finish our class.
Ya,
Okay,
Dokter.
alright. Yeah.
Faham. Thank you.
Okay. Now that's good. Thank you. Now we have the arithmetical checking. Okay. What is the arithmetical checking? Arithmetical checking is to make sure that your job or your works on site is correct. Okay. So the formula is you total up all your backside minus with all your total foresight. You can see the minus sign here. So you get 3.45 minus 2.231 equal to 1.219 meter. Where you get this value? Where you get this value? Again, this one. Where you get this value? This one. So how you get 3.45? 0.63, 0.6663 plus with 2.787. So you get this 3.45. This one also, you are sum up the value between 1.585 and 0.646. So you get this value. So this one assumption of a foresight, and this one is we call it your assumption of the backside. You sum up all. Okay, so you get this one. I think this one is clear. Okay, how about this one? Assumption of rise and assumption of fall. So you get this one, 3.079, and you observe 1.6. Again, coming back here. All right. So let me wrap first. All right. Thank you because you are being so patient. Okay, you look at this point. What is it? You look at this point. What is it? So this one is the total of rise reading. This one is a rise reading, and this one is a fall reading. So how you get this one? 0.938 plus with 0.517 plus with 1.052 plus with 0.572. So you total up all. So you get 3.45. 0.79, this one assumption for the rice. Okay, and this one also 1.283, you plus with 0.145, you plus with 0.432, so you get this total sum equal the total sum of the fall. Alright, based on these two reading, you minus this one, so you get 1.219, and if the answer is same, mean that your data is good, the validity is good. But when you say good, check the final result level and first result level, where you get it from here, from this point. Okay, final result level, I know this one, and your first like this, same like this, same, sama. Okay, you minus this one. Alright, so you get this one. Final result level minus first result level, you get 1.219. Alright, if this reading, final result level and first result level, the reading is 1.29, and this reading is same with the assumption of rice minus with the total sum of fall, you get same, mean that you have good. And again, you double check with the, we call it the total of back side minus the total of front side, again you get 1.29, mean that your work is acceptable. Your work is acceptable. Okay, the answer if one, we call it, for example, that's you have this one 1.29, you have 1.29, it's okay. Here you get 1.20, 1.20. So if you get this value, your work is unacceptable. So as a civil engineer, you must check this one before you proceed to become a drawing and to do the design. And we must redo our survey work. We must redo our survey work. Okay, so you are the engineer who should be answerable where you want to reject the data or when you want to accept the data. That is how we teach you to become a supervisor. And the difference, you as engineer with your technician and technical assistant. And most important, the survey works. Normally the surveyor do it. They are the professionals sometimes. But if they cannot give you this data, don't accept. Don't accept until they prove it, or you can check based on the data they supply to you. Alright? So again, this is another example, but you still remember that this one is RAS M4, right? RAS M4, right? Now we're going for next. We are booking like HOC, height of collimations. So this is the raw data, they get it. Okay, so how they control this one? Like this. Alright, how they solve? The data may be same, the data may be same, the data same, but the solution is different. Okay, this is the solution. So how? Let me have a pen, a small pen here. With the red color. Alright, okay, so you can see that this one is same 0.663, So how we call it? We get 99.423. How we get this value? It's very easy. So you already know that the mean sea level 98.76. You copy to this level. You just copy and paste. Copy. You put it here. Then 98.760 you plus with this one. Backside 0.663. So you get 99.423. I show you 98.760. Okay. You plus with this one. Backside 0.663. So you get the reading 99.423. You plus this one, so you get this value. Okay, you get this value. What value this one? Is the height of collimation. Height of collimations. 99.423. Now, after you get HOC height of collimations, right? So you minus with the intermediate side. You minus this one, you get 97.447. 99.423. You minus with 1.008. You get this level 98.415. And 99.4233. You minus with 1.53. So you get 98.270. Okay, and how we get this one? 99.4.3 minus with the last one, 4 side. So you get this value, 97.838. Now you finish. At this stage, you know that at point D, the research level is 97.838. You minus with this one. Sorry, you plus. Because this one is backside. And backside plus. Intermediate and the rest is minus. So you get this one, this value. 100.6. 100.625. And from 100.625, you minus with the intermediate, 2.270. So you get this reading, 98.335. Now again, you take this one, 100.625 minus with 1.218. So you get 99.4.0. Again, you take 100.625. You minus with the last one. So, 4 side. So you get 99.97. And this reading actually same going to this one. Same reading. The answer is same. But the method is different. So the answer is good, same. Sama And but the methodology is different. Is different. Because one using rise and fall method, one is using rise and fall method, rise and fall, and another one we're using a what method? Height of collimation method. But the result is same. Result is same. Okay. And this one, the arithmetical checking is just 2. So assumption of that side, what I doing the previous one in the rise and fall, and minus with the total of 4 sides. So you get 3.45, this one, assumption of backside, minus with the assumption of the 4 side. So you get 1.219. And the second checking is the final reduced level, 99.979. You are minus with 98.760. So you get 1.219. So here in HOC, we just have 2 difference. We're not going to 3 because we don't have rise and fall or the assumption or the total of rise minus the total of fall. So if these 2 same, so you can accept this work. So you can accept this work. So no need to redo your work. No need. So you accept the work. Okay. Accept the works and no need to redo your works. Okay. All right. And if you read this one, is the comparison between the method of HOC and rise and fall. So we have 2. One is HOC, another one is the rise and fall. Okay, after you look at this one, number 1, I think this one the last slide. Maybe we continue on Friday. So HOC, high already mentioned, faster to calculate. The keyword is faster. So ini lawan dia versus. If this one faster, this one is quite late. It's very slow. So it's laborious to calculate. But normally people, I know the student love this one. But sometimes in the examinations or in the test, they sometimes ask HOC. The student going to fail because they don't love this method. But for student, at meantime, please be patient. You learn both sides. I think no problem. Just do exercise. Number 2, if involve fewer calculation, less work, faster, fewer calculation, and this one involves more calculation. But normally the student love this method because it's transparent. Okay, for the height of dimensions, the third one. So you know, no check on reduced level of intermediate point. Example, rise and fall. Kita tak perlu. We no need for rise and fall. Just straight away HOC. Meanwhile, for rise and fall, you must check on reduced level of intermediate points. Number 4, we talk about error. Error at intermediate cannot be detected. Dia tak boleh. Cannot detect because no data for the intermediate one. Exactly right. Like rise and fall. Detail. So at rise and fall, you have capability to check the error in intermediate. You can detect it and correlate it earlier. Or you can reject it, the work, if the work is wrong. So you can detect earlier detection. Number 5, to check of accuracy. This one 3. So this one is laborious. This one is less. But this one advantage, the student love because it's easy to understand. Me also love this one. But this one, less people love. But to study, you must study both. Right? And lastly, for high accommodation suitable for longitudinal leveling and a number of intermediate side. Then, if you compare it to the rise and fall, suitable for fly, level, and no intermediate side. Okay, so that's all. We call it my sharing today. We already have, we call it our slide.
Okay, Doctor.
All right. Hopefully you understand. Okay?
Ya, doktor. Yes. Faham.
Yeah. Yeah. All right. So thank you very much. I know it's very quite tough because we don't have a face to face, and hopefully you understand. If you have any, we call it question you want to raise up regarding to this subject, so please by WhatsApp, Telegram, or you can email me, or you can text me, SMS, and so on. I
Ya,
will answer that. You have your slide, so we can refer to slide, and you also can discuss with me at any time.
okey.
Okay? So
Okey.
by that, thank you so very much. See you
Thank
again. I know it's quite boring because we cannot face to face, but we try to adapt it to make sure that our teaching and learning we are facilitated it very well for our future. So thank you so very much.
Okey, doktor.
See you.
Thank
See
you,
you on Friday.
Doctor.
Doktor, okey.
Thank
Yeah.
you, Doctor.
Thank you.
Assalamualaikum.
Bye.
Thank you, Doctor. Doctor,
Okay.
thank you, Doctor.
Okay.
Thank you,
Bye bye.
Doctor.
Okay. Bye bye.
Thank you, Doctor.
Okay.
Okey.
Thank you.
Jumpa hari Jumaat.
All right. Inshallah.
Okey. Assalamualaikum.